All right, good morning. Batten down the hatches. It is that time yet again. Get ready for Investigation 7. We're talking about displaying data. So, just a heads up, in today's Socrative was going to be most of the investigation. You will need paper and pencil for the first 5 questions, and you're probably going to need at least 2 sheets. You want to pay attention carefully. I'm going to explain each section, then you hit pause when I tell you to, and you're either going to draw or answer the questions I ask you to in Socrative, and this will be your grade. Go slow and careful, rewind if you don't understand something. So to kick it off right now, it says, data that is gathered needs to be organized and displayed in a way that helps the reader make sense of it. One type of graph is the bar graph, and we cover this back in Investigation 5 as well. Bar graphs use rectangles, or bars, to display the data on a grid. But there's a couple other things than just a bunch of rectangles. You always want to have a title that tells you what type of data you're displaying. You want to have labeled information displayed horizontally. This is called the x-axis if it's going horizontally. You also want to have your y-axis information labeled. The y-axis is the information you're displaying vertically. All right, so another little bit of review here that I still see some people struggling with this on their lessons. Does everybody remember frequency tables? And frequency tables always come in 3 columns. The first column is going to have the title of whatever data you're sorting. In this case, we're going to be sorting out some test scores here, and I want to get it sorted by the number correct. The other 2 columns will always be labeled tally and then frequency. And then over here, you want to have the names of the different data you're trying to sort, like how many people got 1 correct, or 2 correct, or 3 correct. And you're going to start off just doing tally marks. Remember, like the first piece of data I have is a 4, so I'm going to put a little tally here for 4. And then I have 2 3s, and so I'm going to put 2 tallies under 3. And then I have another tally under 4, and so on for 2, and so on and so on. We'll speed this up a bit. So once you have all your tallies in place, and I like keeping track of my data by just putting a little line through it, and then you can write down what numbers the tallies represent. So one person got 1 right on the test. It happened 1 time. 4 times somebody got 2 right on the test. 7 times somebody got a 3. 5 people got 4 right. 5 people got 5 right. And 3 people got 100%, all 6 questions right. So this part is review, just remembering how to make frequency tables. Then they want you to take the frequency table data and somehow display it. One thing we also did back in Investigation 5 was talk about vertical bar graphs, remember? And vertical is going to play into it pretty big right now because we're also going to go into a couple other different types of bar graphs. But to start off with, this is the review. So you can take this rough set of numbers and know that the most frequent number correct on the test was a 3, right? The least frequent was a 1. It's a whole lot easier looking at the data when it's displayed out for you in a bar graph than trying to make sense of a raw list of numbers like that, right? Okay, let's keep moving on. So now we're going to practice making a bar graph using a new situation. And they spell out the situation here. It says 20 children in a class were asked how many siblings, that means how many brothers or how many sisters they had. And the data from their responses, as well as a frequency table to organize the data, are shown both here and on page 451 of your book. So they made a little frequency table right now. You can see that 4 kids have no other siblings, no brothers or sisters at home. 7 kids have 1 brother or sister. 5 kids have 2 brothers or sisters. 3 kids have 3 siblings, and only 1 child has 4 other brothers and sisters at home, right? And again, this is all displayed on page 451 of your book. So now they want us to go and using this frequency table, so you'll have to have your book out, they want us to make another vertical bar graph. So if we take a look, I did the first one for you, right? And when you're drawing this, use the blue lines on your paper. You'll probably want to go way big and wide, but this should be a blue line where you have number 1 should be labeled the next blue line. Make those blue lines in your paper work for you. And if we take a look at the data, we know that the smallest frequency we have is going to be a 1. And the biggest frequency we have is going to be a 7. So we're going to need at least 7 lines using the blue lines on our paper to make this bar graph. And once you have number 7, I always like going one more line. You want to be nice and neat. Every bar graph needs a title. We're going to go and title this Number of Siblings of Students in the Class. The title along the Y vertical axis should say number of students, and the first line 1, then 2, 3, 4. The title along the X horizontal axis should say number of siblings. And we're going to go and graph this all out using our nicest, neatest handwriting. On page 451, we can see that the first one, number of siblings 0, that happened 4 times. So I drew that out for you, right? So now we're going to go and look at the data on page 451 of your book very neatly with all the labeling. Draw out the rest of this bar graph. So hit pause. Do problem 1 on a lined piece of paper. Call me over to check when you're done. All right, welcome back. Now we're getting into another type of bar graphs. A little bit different though. These are histograms. And a histogram is a special type of bar graph used to show intervals, a spread of data points with no spaces between the bars. Instead of having just one solid number on our other bar graph, here we have intervals for things that happen between 0 and 10, or between 10 and 20, or between 20 and 30, and so on. So problem number 2 on page 451 is going to say, create a frequency table and a histogram for the turkey weights using these intervals in pounds. They want 11 through 13, any turkey weights between 14 and 16, any turkey weights between 17 and 19, 20 and 22, and 23 and 25. This data is on page 451 of your book. So to start off with the frequency table, I'm going to need at least 1, 2, 3, 4, 5, 6 lines, right? And we talked about making those blue lines on your paper work for you. I'm going to label it turkey weight, then tally, then frequency, right? The data again is on page 451 of your book, and I'm going to start charting it all out here. So my first weight is 11. So 11 falls between 11 and 13, right? So I'll put 1 tally here. 18 is my next one. 18 falls between 17 and 19, so I'll put a tally here. Then I have 21. 21 is going to fall in between 20 and 22, right? Continue on using the rest of the data on page 451. Once your frequency table is all done, then we're going to go and make a histogram, right? You have a histogram example on page 452 of your book. Remember, no spaces between the bars of a histogram. On your data again, you make those blue lines on your paper count for you. It should go almost all the way across your page. It's going to have to be at least 8 lines tall, and you're going to need room for a title, right? Number of turkeys along the y-axis, and no spaces between the bars. Using your nicest, neatest handwriting, and hit pause, do problem 2, the frequency chart and histogram on a lined piece of paper, and call me over to check when you're done. All right, welcome back. Time for a whole new concept. I'm not sure if you've seen these before. We're going to start talking about stem and leaf plots. And the way stem and leaf plots work is the stems are the digits in the tens place. The leaves are the digits in the ones place. And let me explain to you what we mean. Here are the stems, the digit in the tens place. So my first leaf is a 1, so my first piece of data here is 11. My next piece of data here, I have 1 in the tens place and 4 in the ones place. That's 14, right? My next piece of data I have is 1 in the tens place for the stem, 6 for the leaf. A 1 and a 6, that's 16. Now I have a whole nother row and a brand new stem. I have 2 in the tens place and a 0 in the ones place. So that means the data being displayed represents 20. Now I still have 2 in the tens and 1 in the ones. So that's going to give me 21. 2 in the tens place and 2 in the ones place. That's going to give me 22. And 2 in the tens place and 3 in the ones place means this data being displayed is 23. Does that make sense to everybody now? Hopefully, let's move on. So problem number 3 is going to say, make a stem and leaf plot for the second row of weights in the list. This data weight is on page 451. So the big thing to remember here is, first thing you got to do before you start making a stem and leaf plot is organize your data from least to greatest. And on number 3, you're only doing the second row of turkey weights here. So let's take a look. What is my smallest number that I have? The first one up, that looks like a 12, right? The next step up that I would have would be a 13. And so on, and so on, and so on. But you gotta get the data organized from least to greatest before you start putting it out in a stem and leaf plot. So the first stem that I have is a 1. So the first leaf I would have had is a 2, right? The next leaf I would have had is a 3 because I have 2 pieces of data here. I have 12 and I have 13. Go ahead now, continue putting this data in order from least to greatest. Looks to me like the next one up I would have is 14. So under the stem of 1, I would put in a leaf of 4. Continue on now, doing only the second row of data on page 451. So hit pause, do problem 3 on a lined piece of paper, call me over to check when you're done. All right, welcome back. Problem number 4 says use the information in the stem and leaf plots for the first and the second row of weights to make a stem and leaf plot for the weights of all 22 turkeys. So again, the first thing we have to do is organize this data from least to greatest. Looks to me like the smallest number I have in this list of all 22 would be 11, right? So under my stem of 1, I could put a leaf of 1 to represent 11. Taking a look, do I have a 12? Yes, I do right here. He would be my next smallest piece of data. So under stem of 1, put in a leaf of 2 to represent 12. The next smallest piece of data I have, do I have any more 12s before I move on? It doesn't look like I have one. So now I'm moving up to 13, right? Make sure we do all 22 turkey weights. 13, that means stem of 1 and a leaf of 3. Remember, we're using both rows of data on page 451 of your book. And let's go ahead and hit pause. Do problem 4 on a lined piece of paper. Call me over to check when you're done. All right, welcome back. So a little bit more about bar graphs here. And if you're following along in your book, we should now be on page 453. And here it says, suppose Amelia asked the students in her class to name their favorite types of juice, and she displayed the data in this frequency table and bar graph. So she made the frequency table, gave it the title of the data they're sorting, tally, frequency. Only now she's displaying her data horizontally, right? Looks a little bit different. So the bar graph Amelia made is called a horizontal bar graph because the bars run horizontally. And basically the only difference between a horizontal and vertical bar graph is the direction of the bars and the information presented on the X horizontal axis and Y vertical axis. I mean, I could start off with a vertical bar graph, or if I just tipped it on the side, switch some titles around, it'd be easy to display it as a horizontal bar graph, right? Pretty much that's all there is to it. So here it says in number 5 that 60 children were asked to give their position among the children in their family. Their responses were put in the 4 categories shown in this frequency table. So 22 kids said they were the only child. 16 kids said they were the youngest child in their family. 14 said that they were the oldest child. And 8 kids said they were the middle child. And this frequency table is on page 453 of your book. So for problem number 5, they are saying, make a horizontal bar graph for the data in the frequency table on page 453. Be sure to label each bar along the vertical side of the graph with one of the 4 categories: only child, youngest child, oldest child, or middle child. Along the bottom of the graph, they want you to use even numbers to label the number of students. Because if you take a look, this number 22 is pretty big, right? That would have ended up being a pretty wide table. So trying to shorten it up a bit, they're just going to have you number every other number, 2, 4, 6, 8, 10, and so on, up to 24, right? So we're going to start off taking a look. The first one I have for only child, 22 kids said they were an only child, right? So line it up nice, neat, and straight. And I would go up to 22, making a horizontal bar graph then, and very neatly going in and filling it in. Okay, continue on for the rest of it. Hit pause, do problem 5, the horizontal bar graph on a lined piece of paper, and call me over to check when you're done. All right, welcome back. Now, most of the rest of this investigation is going to be answered in Socrative. So, open a new tab in Safari by pressing the plus button on the top right corner. Remember to have 2 different windows open, and then log into Heinz Socrative. So you're going to want one window still running this investigation in YouTube, and the other window in Heinz Socrative, just like this. All right, so all we're going to have to do right now is hit this little plus button right up here to make another tab. It's about that easy. And then we're going to go ahead and just type in Socrative.com. That'll get you logged in. And now I can continue to watch my video and take my Socrative. I'll just press these 2 little tabs either here or here. All right, so our next section we're going to go and talk about now is called pictographs, and we touched on that back in Investigation 5 as well. Remember that a pictograph uses icons or pictures to compare data in different categories. An icon can represent one data point or a group of data points. And in pictographs, it's always important that we include a legend or a key to show what each icon represents. So remember, the icons are the little pictures. You always still want to have a title. You're going to label your categories, and you're always going to have a legend or a key. In this case, one little plate is going to equal 4 students, right? So how many kids said that grilled cheese was their favorite sandwich? Well, if I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have 10 icons, and each icon equals 4 students. What's 10 times 4? It's about that easy. So here they're saying, suppose 96 children were asked to choose their favorite sandwich. The data collected is presented in this pictograph on page 454 of your book. So, time for question number 6. How many children preferred grilled cheese? Hit pause and tab over to Socrative to answer question number 6, the first question in your Socrative quiz. Question number 7. Suppose 96 children were asked to choose their favorite sandwich. How many children preferred smoked turkey? Count the icons. Think about what each icon represents. So hit pause, tab over to Socrative to answer question 7. Check out question number 8. Here they want you to go and draw a second pictograph for the food preferences in which each symbol represents 8 children. So we're not answering this one in Socrative. Let's go ahead and figure out how we're going to do this right now. We got done saying that there are 10 of these icons for grilled cheese. And we said that 10 times 4, we knew that was 40, right? Over here, we know that there's 8 of these icons. And 8 times 4, well, that's 32. This one down here for the smoked turkey is a little bit trickier. We only have 5 icons, so 5 times 4, that's going to give us 20, right? So, but now though, they want a new key. They don't want 4 students for each icon. They want each icon to represent 8 students. And 40 divides into 8 evenly. You would need only 5 icons to do that, right? For 32, that divides evenly by 8. You'd only need 4 icons to represent that. But smoked turkey is a little bit trickier. 20 does not divide evenly by 8. If I was going to go and list this out in icons, my first icon would be 8. My second icon would be 16. I would not need any of these other ones. How can I make just 4 more? Well, if each icon is representing 8, half of an icon would represent the last 4, right? So now let's go ahead and hit stop. Draw a second pictograph for the food preferences in which each symbol represents 8 children. All right, welcome back. Moving on to a new section, circle graphs and pie charts. And sometimes we're interested in seeing how categories break down into parts of a whole group. And the best kind of graph for this is a circle graph, which is also sometimes called a pie chart. And here they're representing the whole group of 1 day spent in the life of a guy named Greg. So this circle graph is on page 454, and Greg's trying to chart out how much of his time is spent in his whole 24-hour day. He does about this much of his day sleeping, this much of his day is dedicated to sports, watching TV, playing, reading, and eating. So our next question on Socrative is labeled 9A, and they want to know in which 2 activities does Greg spend most of his time. You gotta think, what are the 2 largest pieces of the pie chart? So hit pause, tab over to Socrative to answer question 9A. All right, that one wasn't too hard, hopefully. On to question 9B. On which activity does Greg spend the least amount of his time? You want to think, what's the smallest part of the pie chart? Hit pause, tab over to Socrative to answer question 9B. All right, one coming at us from question 10. Which activity takes about the same amount of time as sports? So you take a look at the fraction piece sports and you gotta think, what piece of the pie chart is about the same size as sports? Hit pause, tab over to Socrative to answer question number 10. All right, one more here on the pie charts. Question number 11 says, which activities, so there's going to be more than one, take more time than sports? So you got to think, which pieces of the pie chart are larger than sports? If this is sports, which ones are bigger? Hit pause, tab over to Socrative to answer question number 11. And one more here. Question number 12. List activities that together take about 12 hours. So again, this whole circle represents a 24-hour day. The hint I'm handing out to you is 12 is half of 24. So take a look at where you see half of the circle. Hit pause, tab over to Socrative to answer question number 12. All right, one more type of data display we have to go over. We're talking about Venn diagrams. And sometimes we have data points that fit into more than one category. To display such data as this, we use what's called a Venn diagram. And the categories in a Venn diagram are represented by overlapping circles. All this can also be seen on page 455 of your book. So we might see some scenarios like this. Suppose Kareem surveyed his 21 classmates about family pets. He asked whether they have a dog at home or whether they have a cat at home. With a question like that, there are 4 possibilities. A family could have both cats and dogs. A family could have dogs only. A family could have cats only. Or a family could have neither kind of pet, right? Even though there's only 2 types of animals, there's 4 possible answers. So if we take a look here, and I made them color-coded, this red circle here, labeled dogs, represents the number of kids who have only a dog at home. Over here, the blue circle labeled cats is the number of kids who have only a cat at home. But in the middle, where these 2 circles overlap, are the number of kids who have both dogs and cats at home. And this number down here, that's outside both circles, is the number of kids who don't have either dogs or cats at home. So the important thing to remember when you're starting off with a math Venn diagram, make sure if they're telling you the total, that all these numbers are accounted for. If I add up 7 plus 5, that's 12, plus 3 more is 15, plus 6 more is 21. So I know I'm talking about the entire class. I have everybody represented. So let's take a look now at problem number 13. How many families had just one of the 2 types of animals? The 2 types of animals would either be dogs or cats, right? And you got to do a little bit of thinking here. How many families had just dogs? How many families had just cats? We're not talking about the people who had dogs and cats where the circles overlap. How many families had just one of the 2 types of animals? So think about that and combine those 2 numbers. Hit pause, tab over to Socrative to answer question number 13. All right, time for a new scenario, and this is on page 455 of your book. And it says, suppose Tito asked each of his classmates whether he or she plays soccer. And they want you to refer to the Venn diagram he created to answer the last 5 problems, 14 through 19. And again, I made it kind of color-coded for you to make it a little bit easier. Over here, for the circle labeled boys, is the number of boys who don't play soccer. On the blue circle over here with the blue number 6, under soccer players, those are the number of soccer players who aren't boys. Where these two overlap in the middle is the number of boys who play soccer in Tito's class, right? Got it all straight? Let's go on and try the last 5 problems. So, question number 14. How many boys are in Tito's class? Well, something to think about. How many boys don't play soccer? How many boys do play soccer? Combine these two numbers. Hit pause, tab over to Socrative to answer question 14. Question number 15. How many soccer players are in Tito's class? You gotta go and think. Combine both numbers in the blue soccer player circle. Hit pause, tab over to Socrative to answer question 15. Question number 16. How many of the boys play soccer? I'm not even going to go and write out a hint for you. You should be able to look at this and figure this one out. Hit pause, tab over to Socrative to answer question 16. All right, welcome back. Question number 17. How many of the soccer players are girls? And the easiest way to do this one is think how many soccer players aren't boys. Because if you aren't a boy, you gotta be a girl, right? Hit pause, tab over to Socrative to answer question 17. Question number 18. If there are 30 students in his class, how many girls are there? So you want to think. Combine the total number of boys in the red boys circle and subtract the total number of boys from the total number of students to find out how many girls there are, right? Because if the class has 30 kids and there's this many boys, anybody who's left would be a girl, right? Hit pause, tab over to Socrative to answer question 18. And our last one. If there are 30 students in his class, how many girls don't play soccer? So your hint here is to think. What was the total number of girls in class? That was the answer to problem 18 that we just did. So if you got that right, subtract the number of girls who do play soccer, otherwise known as soccer players who aren't boys. Subtract that number from the total number of girls in class. The answer you just gave for number 18. All right, hit pause, tab over to Socrative when you think you got it. And that is the end. You can only miss 3 in the Socrative portion of this investigation. Go slow, go careful, so if you ended up missing more than 3, you're going to have to back up and try it again.